So hi friends, I am again from today. So I'm going to explain about that experiment we multi-layer perceptron on any non-linear separable data. So experiment 3 multi-layer perceptrons on any non-linear separable data. So I am Madhavan from AI multi-perceptron. So I am going to explain the experiment. So let's see the introduction content. So we are going to see the 8 steps to solve the program. So first step is to introductions and library imports, and second step is the data initializations and setup. So third step is a sigmoid activation function definitions, and fourth step is forward propagation functions, and step 5 is back propagation functions, and step 6 is training loop and loss calculations, and step 7 is prediction functions. Step 8 is predictions and output display. So step 1, introductions and library imports. So general steps that are to be imported in the library. So we import the necessary libraries like NumPy, Pandas, and Matplotlib in the starting stage of code. So import NumPy as MP and import Panda as PND, import IO, and import Matplot lib.pyplot as PLT. So step 2, we are going to initialize the data initializations and setups. So we are considering and we initializing our input features as x and corresponding labels y. Additionally, we check the learning rate, initializing weight randomly, and prepare to track our lost values. So this is the code for that checking the datas and initializing the setups and datas. So first we giving an x in array value forms and y as an array value forms. So for x values we have two arrays and y values we have one array, and for this it shows the maximums of the what uh, and m is equal to x dot shape. So lr is equal to 0.1 np dot random dot c. So w1 is that weight randomly chosen, and they taken that weight as w1 and w2 and losers, and tracking the losers weight. So sigmoid active sigmoid activations function definition. So we define the sigmoid activation functions, which is crucial for introduction non-linear into our neural networks. So this is the code for the sigmoid functions. So we need to follow this code for the sigmoid activations. Step 4, forwarding propagation functions. Uh, we define the forward propagation functions. It computes the activations of we define the propagation function. This step it computes the activations of each layer in our neural network. So this is the propagation functions for forward propagations. So this is for backward propagation functions. So we define the back propagation functions. This step is crucial for training our network to make accurate predictions by minimizing the error between the predictions and actual output. So this is for the back propagations. Step 6, training loss and loss calculations. So we enter a training loop iterating over a specific number of epochs. So it is a iteration. So this much iterations will be carried out as a training loop, and it will be ranges from something from the iteration from 0 to 10,000 something, and it will check for the losses and the weights and plot the losses and epochs and loss values in the x level and y level. So this is the output for the step 6. So it is plotted as a x label, y labels, and loose values is 0.5 to something 0 comma 0 points. So so step 7 is a prediction functions. We define the prediction functions which takes the learn weights and input data as input and predicted the corresponding output. So this is for the prediction functions, and so we use that weight values as an input, and we are going to use the forward propagation values, and we check if the a2 is greater than or equal to 0.5. We will print I0 for I in input will be 1, and it will be 0. So step 8 is our predictions and output displays. So we going to give a predicted values, and we get one predicted output as a display. So we test our trained models by taking making predictions on different input samples. It allows us to observe how well our MLP performs in classifying the given data. Print input comma output. So we are going to test each and everything, and we will print the output for 1 comma 0 and 1 comma 1 0 comma 1 0 0. So this will be the output and the input. So applications of MLP. Applications of multi-layer persistence MLP includes pattern recognitions, financial forecastings, natural language processing NLP. So thank you.